a little annoyed. I got woken up in the past hour because 4 different people called our landline and it was going off and it woke me up. I've never had 4 people in the last hour or in 1 hour call our landline.
Wow, that sounds terrible.
No, I know, worst day of my life.
Wow. Yeah, I don't really use my phone anymore. I haven't used my phone for years, except for my brother and my mother. They're the only people who call me. And once in a while, an emergency, like the car is broken down. Um, but every now and then, I look, and wow, I get like so many phone calls every day, and they're all spam. And I never have my ringer on unless I'm expecting a message from someone. So, but I look at it once in a while, and it's crazy how many phone calls come in on any given day. And I don't know what all these people are calling me for, but um, and I don't answer, right? I suspect if I answered, I'd be getting 10 times as many calls. But phone is just kind of a strange way to communicate sometimes. Um, so anything anybody wants to talk about up front here? Let's start with that. Otherwise, I got a whole bunch of stuff to say and do and go through and work on. Struggling to find a group for PA5. So PA5, so PA4, almost nobody worked in a group. And that's fine, but I recommend considering getting into a group. It doesn't mean you have to have, long drawn out group meetings. It doesn't mean you have to, get mired in organizational tasks and so on and so forth. It can simply be, hey, let's all do our own thing and pick one project to turn in at the end, but let's help each other, and being able to get most of your code working, but I'm having trouble with this one thing, or when I try to close the connection, everything hangs up and so on. 2 or 3 heads can be better than one. And as you move to university, you're going to find more and more group work and situations where you're going to be required to work in groups, and situations where you may be assigned to a group and you'll be, required to work with people that you've never worked with. And some of them, may be excellent people to work with, and some of them may, never respond to emails and never show up for meetings. And this is part of the business, right? And when you're on the job, you're always going to be working in groups. It's fairly rare that you're going to be working on something by yourself that isn't, somehow passed off or taken from somebody else. So it's good, a good skill set to develop anyway. And I think it makes PA5 more fun, especially since you're trying to play a networked version of DOTS. Having at least 2 people working on this gives you some opportunity to sort of enjoy the outcome of that. So Discord is always an option to say, hey, I'm looking for a group. Is anybody interested, and so on. But if you're looking for a group and you're not having any luck, send me an email and say hey, I'm looking for a PA5 group. And if I get multiple emails from different people, I can start putting people in touch with each other, if that's okay. So if you want that, send me an email and say, hey, if you know of anybody looking for a group, can you give them my name, and I can help with that. But you can also just hop on Discord and do that. And like I say, almost no one, I think I had 2 groups, maybe 3 for PA4. So most people were solo, so there may be other people looking. All right. So there's no class on Monday. Monday is Memorial Day holiday. So we won't have our regular class meeting. And so I won't see you in class for a week after today. which is kind of a long stretch, right? Because then your assignment is due on Friday. So a couple of things. One, you're definitely going to want to rely on office hours between now and then. Email is not working as well, so I mentioned maybe in here or the other section. I looked back, and in 3 weeks I had 400 emails, and almost half of those were from students, and they were emails that I responded to. And that's not a viable load that I can maintain, particularly at this point in the quarter when there's, end of quarter, end of year stuff coming up. So office hours are your best bet. The other thing is, since I try to keep these two sections in sync, Tuesday, so a week from yesterday, I'm going to run as an open lab. Meaning that I'm not planning to lecture on new material in Tuesday afternoon's section. And instead I'm going to use it as an opportunity for people who want to come in and, talk about PA5 or ask questions about it or screen share and so on and so forth. And so that's going to be Tuesday. Let me get a date for you. That's going to be May 31st. And that's from 1 o'clock to 3:10. And that's going to be in the Zoom office. And people from this section are welcome to come to that. That's the regular meeting time for the Tuesday section. But instead of meeting in the 223B Zoom room, I'll be in my office on Zoom instead. And for those 2 hours, people from either section can come in and ask questions about whatever, screen share code with me in a breakout room, ask for help, and so on and so forth. So that's available to both sections, and that'll be Tuesday. And I'll post announcements on Canvas later on today, reminding people of this information. So no class for us on Monday, and then Tuesday you have an opportunity to come in, find me in my Zoom office, and use that as a chance to work on code. Alright, does that make sense?
Are you going to post an announcement on this?
Yeah, I'll post an announcement later on today on Canvas. Probably tonight.
I do have a question about my SLP.
Yeah.
Because project's due on Monday in the morning, right?
Yeah, the written report is due Monday morning.
I was not working on it, but I kind of got stuck on some of the stuff. Mostly because when I was working on my SLP project, it's not complete, but the concept is done, at least.
Cool.
So, what do you expect the report to cover mostly? Is it a problem solution paper, or is it just like a report on progress overall?
It's the whole shebang. So here's one way to think of it. In fall, you proposed a project, right? So imagine that what happened in fall was you went to a bank and you said, hey, I've got this great project I want to work on. I need $1 million. And they said, okay, we'll give you $100,000 now up front to get you started. Okay? What you're turning in Monday, that's the thing you give to the bank at the end to say, hey, can I have my other $900,000? Well, before the bank gives you that money, they're going to want to know, what did you do during this time? What did you spend that money on? What have you done that's worth us giving you this $1 million? Did you do what you said you were going to do? If not, what did you do instead? Right? What problems did you run into? Did you tackle those problems? How did you tackle them? What did you come up with? So if you came up with, the thing that you were proposing in the beginning, that's pretty easy, right? You can just talk about that. You can have code and circuit diagrams and whatever else. If you ran into problems, which is usually what happens in SLPs, right? You can talk about, well, I was going to, make a cold fusion reactor, but then I found out that I couldn't get a hold of plutonium, and so I switched to aluminum foil instead, but that didn't generate much heat. And here's a picture showing, the expected outcomes, and or whatever. So it's really a presentation on the service learning project, right? Which can be the actual, thing that you were trying to produce, but it's also, the process that you went through. If you were working with someone and they left, right, you can have, a few paragraphs in your report that say, the original plan was I was going to work on this and somebody else was going to work on that. And then that person left the group. And I was not able to pick up that piece, and so I changed the focus of the project to something different so I could do both of those pieces. But then I had to go back and I had to learn such, and so here's what I did for that, And it's kind of a story of your project. But also including, enough technical detail that whatever you came up with at the end, if you came up with something that tracks hand motion or things like that, that somebody reading this report can understand exactly what you did and ideally be able to do the same thing themselves. So there's no minimum number of page requirement for this. It's not like I'm going to count it and I see 9 pages and it's like, oh, that's going to be such and such a grade. But if you're really putting in all of this information from what's been 30 or 40 weeks worth of effort to varying degrees, you're going to find a lot to talk about. And if you've taken the project to a very advanced stage and you've produced working prototypes of code or hardware or things like that, you may find it hard to turn in a short report. You may just keep writing and adding more and more information. Your report might end up being very long. So it's not that I'm worried about the number of pages, right? But if your report fits on 1 page, it's probably not putting in enough detail. Even if, between you and me, if you've never done anything on your SLP until this weekend, right, and you try to do it all in 1 weekend, you're still going to have more than a page of description, goals, competitive analysis, research, requirements, materials, procedure, what did I do, what did I come up with, and so on and so forth. Where does this project currently stand? Did I meet my target milestones? If not, what went wrong, and if I had more time, could I meet these milestones? Or would I change these if I was going to continue working on this to something different? And what's going to happen after this? Am I going to continue working on it? And if I had, different resources, if I had more money so I could buy more hardware, where could I take this project? Where would I like this project to go? Right? Am I still excited about this, or did I lose interest in it? Would I like to see a company formed that would be able to produce whatever it is I'm imagining on a large scale? Have fun with it. Think of it as if you were doing this as a business proposition, maybe. You can practice marketing yourself a little. Or you can be, very bare bones, kind of technical, factual based. But you can have some fun with it. Is it okay if our final product isn't exactly what we planned for it to be? Definitely. It would be very rare that your final product is what you originally thought it was going to be. That would be exceptional, as in not the usual situation. Usually, you start off and you say, this is what I want to do, and as you work towards it, you have to make adjustments. you have to change the scope, you have to maybe, change direction. You may have to say, that's not at all something I can do. And so, I started off, I wanted to make a 3D VR, video game, and I ended up with a side scroller, right? And it's a side scroller that actually you can't shoot, but you can move around. And that's totally fine. The goal of the SLP is education, right? The goal is to have the experience of imagining a project, putting down some milestones, working towards those, monitoring your progress, adjusting what you're working on, adjusting your milestones, adjusting the targets. That's the goal of the SLP, is to get that experience. If you happen to set this up in September, and everything worked exactly according to plan, you hit all your milestones, and this weekend you're done, and here's exactly what I was after, that's fantastic. I would say you have a gift for project management and invention and so on and so forth. It really doesn't happen very often. So yeah, definitely you can adjust along the way, and that's fine, and that's all information that's good to put into your report. Because the process of recognizing when changes need to be made and making those changes, that's an important skill set, right? That's something employers will love you for, because not every project works out the way it's supposed to, right? So I had a project I was working on, and all of a sudden the parts that I needed for it, global shortage, and those parts were unavailable for 18 months. And so how do you keep manufacturing this product when you can't get the parts you need? Well, so you gotta change something. You gotta change the design, and maybe changing the design changes something else about the product. Maybe the shape changes. That's a really valuable skill set. Yeah. I think my project had me learn too much, such as having a strong knowledge of Python, so that was the part that shortened my expectations. Yeah, and this is again, really valuable experience. Um, and it's never a failure, right? Whatever the outcome of this is, it's not like it's judged by what's the quality of the product you created in the end. It's really what did you learn in the process. And it can be technical skills, it can be so-called soft skills, right? Maybe you learned about how to choose people to work with, and how to assess how a partnership is working, and how to manage teamwork, working in a team, and how to make adjustments when the team changes. Those are amazing skills. And that might be the big takeaway for someone's project, rather than, hey, I learned how to make video games in Unity, right? Maybe the big thing you learned was how to manage a project with multiple people. I mean, that's great, a great outcome. So I understand the reality that a lot of people, they turn in a proposal for an SLP when a proposal is due, they turn in a paper when it's due, they do a presentation when it's due, they upload a poster when it's due, and sometimes not a lot of stuff happens in between those, right? That's not a surprise to me. I was a student, right? But hopefully, if this is a project that you had some interest in, hopefully there's been some more effort in there, right? It's unlikely that most people hit the mark of, well, I'm going to spend 3 hours a week working on my SLP. That would be great. Probably doesn't happen, right? Because 3 hours you could use that to sleep, or eat a hot meal or something. But hopefully there's been some effort in between the required uploads and such, and whatever that effort is, right? It usually gives you enough to talk about in a report, and then leaves you with something that you can talk about and or demo to people in the presentation that last week. All right. Any other questions about service learning project? Just make sure you upload your report by the deadline. I think Canvas closes it at that point, and the reason is, again, at this point of the quarter and this point of the school year, scheduling gets really tight, and so I'm earmarking certain periods of time to grade certain things. And when an assignment closes, right, my plan is I have all of the things that I'm going to grade, and I can start working on those at that point. And when things kind of trickle in over time, that gets really hard to manage schedule wise from the teaching side of things. So those deadlines for SLP upload are pretty strict. And once I download those SLPs from Canvas, that's probably it. I'm not gonna accept other late entries.
I do have a question. This doesn't apply to me, but applies to anybody who probably have like things happen in life, like if there's any emergency, like family emergencies or anything that's like that was wrong in the background. Is it possible they could send you the SLP late if something were to happen? Like send you an email saying like, you know, I had a lot of family issues and I didn't get my report done or something.
So my suggestion would be, you know, send me drafts along the way. And if something happens and you can't send in the final report, I could use, you know, the last draft that you had available, and that would be better than not having anything. Certainly, if something significant happens, if you know there's some kind of emergency and you have to be at a hospital or be out of town, right, for 3 days in a row, and there's no way to get the SLP done, right, we can talk about that. You can submit documentation, and you know I'm going to be reasonable about that, but everybody has emergencies, right? I guarantee there's probably nobody in this class who's going to sit down and say, hey, I'm going to spend this weekend working on the SLP without having something come up or multiple things come up. And it can get out of control really quickly. And so when I say I'm going to require documentation, it's not a question of trusting people. It's not that I think people are going to lie. It's that I want to make sure that if I accept this person's SLP late, somebody else doesn't come along and say, hey, I turned in a really rushed job, you know, and I could have turned it in late, and that's not fair. Or somebody says, I decided not to finish my math homework so I could do the SLP, and then I heard that you let so-and-so turn it in late, right? And that's not fair. So I need to be really, really careful about that. And you know, turning in drafts is a good way to sort of mitigate the unexpected. As you work on it and you develop drafts, just keep turning them in, and I'll grade whatever the latest one is at the time that I download. All right, other questions? And it might be annoying if I say have fun with this, but I don't want this to be, you know, the Grim Reaper of CSE223 that, you know, haunts you and so on. You've turned in tons of lab reports, right, in 120, 250, 270 if you've done it, and you turn in homework, right? Same idea, right? I just want this to be, you know, formatted like a formal report. So not just, you know, bullet point answers to the points that I mentioned, but, you know, complete sentences, paragraphs, sections, stuff like that. All right, let's talk about sockets. So we played with server sockets the other day, and we saw that we could create a server socket in Java, and then we could use that to receive connections. And we've been using Telnet as our sample client code. So I wanted to look at sockets, separate class from server socket, to see how we can create the client side of a connection, and then use that to do two-way communication, and that will give us enough to talk about some more detailed pseudocode related to PA5, and that should close the loop on PA5. So I'm going to do my imports, java.net.server socket. And we're going to use the print writer scanner pair that we used before, so we'll do java.utility.scanner. And we'll do java.io.printWriter. And let's put together our server side. So let me change the name of this. So this is going to be the server. This is going to receive connections. So server socket SS, scanner to read from the client, a print writer to write to the client, and a socket called client. All right. So this is just quickly running through code that we wrote a couple of days ago. So we'll make a socket on port 1234, and then we'll say client equals ss.accept. So we'll receive a connection. And we'll print out the client. And then we'll construct our input-output streams and use those to make a scanner and a print writer for communicating with the client. So make scanner and print writer. So from client equals new scanner. And we're going to construct the scanner using the input stream associated with the socket. So the socket is called client, and we'll say .get input stream. And then the print writer, we're going to call that to client. And we'll construct that using the output stream associated with the socket. So the socket is called client, and we'll say get output stream. And if all of that works, we're good to go. We can use those now freely. And if not, we'll throw an error message. And we'll return. So here we're ready to communicate. So what should we do? Let's make a square root server. So this is a server. We can send in a number, and it sends back the square root of the number. So how do we do this? So while from client has next line, so is there a message coming in? So let's read the next line from the client. Let's convert this to a double. So if we look at the documentation for the double class, so there's a static method called value of string, return a double object holding the double value represented by the argument string s. And this is static, so we can run this as double dot value of. So let's use that. So double number equals double dot value of message. So we'll calculate the square root. I'm just going to call this a double with a lowercase d. So square root, we get that from the math class, and it's a static method, math.square root parentheses num. And let's send this back to the client. So to client print line so here I'm doing this trick where I concatenate to a string which says, hey, let's take this thing and turn it into a string. This is a double. I can't pass a double, well, I can pass a double to print line actually. But this is taking it and concatenating it to a string, so it turns it into a string. So this whole thing will be a string of characters representing whatever the square root of our number was. And I put that as an argument to print line on the to client print writer. And that should send that string to the client. And we remember to force the output by calling the flush. And then we'll go back to the top of the loop and get another number from the client. So once we exit the while loop, it means that this has next line has returned false, which means the client exited. And so let's just print a message. And we'll just say client has closed connection. And that'll be the end of our whole method. Alright, is this going to compile? I'll take however many errors I have and buy a lottery ticket based on that. Oh, one error so far. From client. Alright, not bad. Let's run this and see what it does, and then we'll write the client side ourselves. So right now this is running, it's listening to port 1234. I'll telnet to localhost port 1234. Receives the connection. I should be able to send a number, so let me send a 25. and it gives me back 5.0. I can send it a 2, it gives me back the square root of 2. How cool is that? There's a square root of 17. And if I close my connection, then it tells me client has closed connection. And we're being pretty sloppy, right? So if I were to send it something like, -1, well, I can't get the square root of -1. Fortunately, the square root function returns not a number, because it's an imaginary number, right? So that's okay. But if I say, ha ha ha, I throw an exception in my server. Well, if this was a web server that was supposed to be serving square roots to 1 billion people, and someone says, ha ha ha, my whole program just crashed, right? Because I used this value of, which uses parse double, and that can throw an exception, and I should have put that in the try-catch block. So we're being sloppy in here. Yeah, that's control plus right bracket. So if you do a telnet, hold down control, press right bracket, that brings you back. Yeah, that is fun. All right. So that's the server side, right? And this is a repeat of the kinds of things we used in sample code already. So let's make the client side. So let's start a new class called client.java. And we're not going to need a server socket, but we'll still need a socket scanner and print writer. All right, so let's make the client do the following. Alright, we're going to write our own little version of telnet here that's going to connect to port 1234 on the local machine, and it's going to ask the user to type in something. It'll let the user type in something, it will take whatever the user typed, send that to the server, and then read a line back from the server and print that out. And it'll just do this in a loop. Alright, so we're going to have a socket called, server. That's the socket that's going to connect to the server. We're going to have a scanner called from server. And we're going to have a print writer called to server. And I'm going to make a second scanner called standard in. Which is how we're going to get information from the user's keyboard. Alright, so instead of creating a server socket, I'm going to create a plain socket. And the constructor I'm going to use is a constructor that takes an internet address followed by a port. Right? Or a string followed by a port. Let's do the string version. So this is the client side code. So what does this look like? So this is going to be server equals new socket localhost 1234. So let's connect to the server on this machine. We don't have an equivalent accept call. Once you construct a socket, if the connection is accepted, you'll come back from this call, and this will be the socket that you can use to communicate. So we can say connection accepted, and let's just print out what the server looks like for kicks. Make scanner and print writer. So to client is going to be for writing to the client. Sorry, to server. And from server. Alright. Make a new scanner using the input stream of the socket that we've connected to the server. And we're going to call that from server. And then make a new print writer using the output stream we get from that socket. And we're going to call that to server. So we can write to server. The server will pick that up. We can read from server, and that will give us anything that the server has sent to us. And we'll do those in try catches. And we need a scanner for reading standard in. So we'll just do our new scanner on system.in. Now we're ready to communicate. So what does this look like? So while standard in has next line. So this will wait for input from the user. And then message will be standard in dot next line. Let's prompt the user. So we'll prompt the user, please enter a number. And then we'll wait for the user to type something in. We'll read in what they type. That's our number. Let me call this just string number. And we're going to get rid of all of this. Let's send that to the server. So to server print line number. So we'll send the user's number to the server, and we'll wait for an answer. So string answer equals from server dot next line. And then let's show this to the user. And then we'll go back up to the top. And we'll wait for another number. If we come out of this while loop, it means that the user hit Control D or somehow hit end of file, and the client is done. So we'll just say client is exiting, and we'll do a return. And that's the end of our client side. So it's not a whole lot of stuff going on in here, right? This is all the setup. So creating the socket that's connected to the server, creating the scanner and print writer for reading from writing to that socket, creating another scanner to read from standard in, and then we just have this communication loop. Which prompts the user, waits for a line to come in from the keyboard, takes that line, sends it to the server, flushes it, waits for an answer from the server, prints out that response, and then prompts the user for another number. Now if I run this right now, it's going to get upset, right? It's saying error, connection refused. So that's an error coming from one of these statements in this try block. In particular, it's coming from this socket constructor because there's nothing listening on port 1, 2, 3, 4. Why? Because my server is not running. So let me open up a new window. And let's just do Java server. So now we've got our old server code running over here. And let's go ahead and run our client again. And so this looks good, right? The server said, hey, I received a connection. Came from port 5810. And my client said my connection request has been accepted. And the local port number is, guess what? 50,810. So the server and the client are talking through the same socket, right? We've got a connection set up. And so I can enter a number like 81, and that 81 gets sent to the server, and the server responded with a 9. And I can say enter another number, and there's a 2, and it responds with the square root of 2. And then if I hit a Control D, that tells this client program, hey, I'm done entering input. We get to the part that says client is exiting, and we return, and when that happens, the server detects the connection has closed, and so it exits also. Right, and if I type in something bogus like a /25, I put a slash up here. Let me do a better example of that. There's the server, there's the client. So 25 is fine. If I say hello, right, my server blows up, as it should. And then when I tried to read the response from the server, this code blew up because there was nothing coming in from that scanner. Because when when the parse failed, this thing closed its connections, right, because it exited. Yeah, that would be fun for the 20 questions game, because then you could have people, on other locations playing it. All right, so let's take a break right there. Think about this for the next few minutes. And then let's talk about how this relates to PA5, and let's add those final pieces to that layer. So we'll be back in 5 minutes. All right. Any questions so far on this code, the client side or the server side?
Nothing at the moment for me.
All right. So this code's on the server, the Linux server, right? And you can use this as kind of a boilerplate, right? So not everything that I do in class applies directly to a programming assignment, right? But some of it does. And the kinds of things that we're doing in here, the way we construct a socket and bind it to an address, right? There's only so many ways to do this. Right, so in your PA5 on the client side, you need to specify the machine you want to connect to. So let's go back to a sample executable, right? If you're the server, you just hit the start button. If you're the client, you specify what machine you want to connect to and what your name is, and then you say connect. So that connect button can do the following, right? It can construct a socket, and instead of saying localhost, use a get text on whatever this text field is called, so that if someone says, 192.168.0.1, right, that's the name of the machine you're trying to connect to. The 1234 is hardwired. Assuming the server is already running, this connection should be accepted, so you should automatically come back from this call to the constructor, make your scanner and print writer. There shouldn't be any exceptions. And then when you're ready to send something to the server, you can just take the name of that socket and say print line and follow it by a flush. And when you're ready to read from the server, you can just say, name of the server dot next line. So the network pieces of PA5, you can find code right here that's very, very similar to what you're going to do, right? The challenge is not so much, what is the print line method, for a socket, right? The challenge is, where do we put these pieces into PA4 to turn it into PA5? How do we incorporate this? So if you're the client, right, your interface looks like this. This is the host name for the first argument to the constructor. If you're the server, your interface looks like this, and you just have, your server name, your player name, and a start button. And so what does that start button do? Well, it creates a server socket. And that's going to look just like this, because you want to be on port 1, 2, 3, 4. And it waits for a connection. And when the other player, who's the client, hits connect, you'll come back from this, you'll receive a socket object. You can construct a scanner and print writer on that, and now when you want to talk to the client, you can send them a message by saying, the name of that print writer dot print line, followed by name of the print writer dot flush. And when you want to read a message from the client, you can just say, from client dot next line, and that will give you whatever the client sent you. So even though, you don't want to take most of this code and use it in PA5, it contains, good examples of things that you will be doing in PA5. All right. So how do we incorporate these things? So let's let's look at some pseudo-ish code. So what does PA4 look like? So you have a bunch of initialization you do, right? So initialize. And this may be, you know, creating an array of boxes, setting the booleans to false, setting the initials to be blank. Maybe if you're keeping track of score and variables, setting those variables to 0, and so on and so forth, and calling repaint at some point to display the board. So some sort of initialization, and then we enter a main loop. And we're not looping in our code, we're basically returning from our main method. But swing is doing something like a loop. It's hanging out waiting, but really everything is event driven. So the only other piece of code we need to write is what happens when the mouse gets clicked, right? So this is PA4 still. So when mouse is clicked, what do we do? Get XY coordinates. So, you know, use the mouse event.getX and .getY methods. So get the XY coordinates. And then we do a series of steps. So find what the row and column are, find the edge, check the legality. So make sure they clicked somewhere where there's not a line already drawn. Assuming it's legal, set the booleans. 2 booleans if that line completed 2 boxes. Check to see if a new box or new boxes have been completed. Adjust the scores. Adjust whose turn it is. So if a box was not completed, the scores don't change and it becomes the other player's turn. If a box was completed, somebody's score will go up and it will remain the current player's turn. So adjust might mean, you know, do nothing, or it might mean change to the other player. And then repaint and return. And that's kind of your whole PA4. There's mechanics inside your paint method of your panel class to make the paint, to make the board appear, right? But the parts that interact with mouse events and update memory, it's really this, right? You get a mouse click, find the XY coordinates, find the row column, pick the edge, adjust the booleans, adjust the state of the game, the score, whose turn it is the game over yet, and so on and so forth. And then call repaint. And repaint makes a call to the paint method, and the paint method goes through these booleans that you've updated and you know, draws the lines where they should be. If there's an initial for a completed box, draws the initial, and so on. All right, so that's PA4, right? And I'm going to take all of this and I'm going to call this process click X comma Y. And I'm going to say return. So I'm going to change my mouse listener to more or less one line of code, which says, hey, let's just call process click on e.getx, e.gety. And I'm just going to modularize this code. This code is going to be process click. X comma Y. And process click is going to figure out what the row and column are and do all of this other stuff. So I haven't changed anything. I've just taken most of these steps and put it into a separate method. And now my mouse listener is one statement effectively, which says take the XY coordinate of the mouse click, call this process click function. So how does net dot work? So we do the same initialization. Including swapping names. And we'll talk about how to do that.
Your dock pan focus is being weird. I don't know if you noticed.
Thank you. That should fix it. All right, so net dot, we do some initialization in the beginning. The initialization is going to include setting up the network, so making a server socket or a socket, accepting, and so on and so forth, and eventually swapping names. And we'll drill into that in a minute. But now we go back to just kind of like hanging out until a mouse is clicked. All right, so if it's not your turn, just ignore it. Right, so PA5, you only get to do half of the moves. After you make a move, it's the other player's turn. So if it's the other player's turn and you click your mouse, it's a no-op. You can, put a message saying, hey, wait for your turn or something like that, but we're not going to do anything. So that's one difference, right? Over here, whoever's turn it is, well, they're using the same mouse in PA4, so anytime somebody clicks the mouse, we're going to do all of this stuff. But in PA5, you're controlling a mouse for one player, somebody else is controlling a different mouse for a different player. So when you click your mouse, you have to check to see if it's your turn, and if it's not, it's a no-op. Okay? If it is your turn, what do? You get XY coordinates, and we call process click. Which does all of this stuff. So far this is identical, except we do this extra check to see if it's our turn. And then we do one more thing at the end before we're do this final return after process click. We send XY to the other player, and then we return. So your same mouse listener code as before, except in the beginning, if it's not your turn, get out of there, just return. If it is your turn, do all the stuff that you do in PA4, but at the end, before you exit the mouse listener, send your XY coordinates to the other player. And we'll talk about how to do that in a few minutes. Alright, that's the whole change to your mouse listener for when it's your turn. And then we have one other piece. We have a new thread which I'm calling net thread. And so part of the initialization is create a new thread. And what does net thread do? Net thread is a loop. And it does three things. It does two things. Receive XY from the other player. And once you receive that XY coordinate from the other player, what does that tell you? It tells you the other player clicked their mouse at XY. Well, what do we do in PA4 when the second player clicks the mouse? We do all of these steps. We do exactly the same steps as when player 1 clicks the mouse. Right? There's nothing in your code that does anything different except maybe some booleans have changed value, or an integer that says whose turn it is has changed value. But the code is basically the same. So logically, when the other player clicks a mouse at position XY, what do we want to do? Just call our process click. And that's it. We're done. Go back up here and wait for another message. And this handles the other half of the game where the user is making a move on the other side. So the whole net thread business is new. Net thread. And that's going to run, as an independent stream. It's a thread, so we're going to make a class that extends thread, and we're going to make a run method that does whatever setup needs to be done and then sits in the loop doing this. And this can be, while from other player dot has next line, we'll read the next line, we'll parse it as a pair of integers, and then we'll call process click. So this can take some getting your head around, right? But PA4, if you think about it differently, right, waits for player 1 to click a mouse, and then calls process click on player 1's coordinates. And then it waits for player 2 to click the mouse, and it calls process click on player 2's coordinates. And then it waits for player 1 to click the mouse, and it calls process click on player 1's coordinates. Well, your code in PA4 has no idea who's actually holding the mouse, right? It's just assuming that players are taking turns with the mouse, right? So that's the sense in which I say you wait for player 1 to click, you call process click. You wait for player 2, you call process click. Well, that's what's going to happen in here. If you're the server, you're player 1, first you're going to wait for a mouse click, you're going to call process click. And now it's the other player's turn, and when the other player clicks their mouse, right, this thread will pick up those coordinates and call process click. So this is the thing that's waiting for player 2's turn. And after process click is called, well, this has been waiting for a mouse click all along. And so when a mouse clicks, right, it gets the coordinates from player 1, it calls process click. And so we're taking what used to be player 1, player 2, player 1, player 2, and now we're doing it as player 1, player 2, player 1, player 2. I could describe this 10 different ways. It's either going to make more sense or it's going to get more confusing. So I'm not going to do that. But think about this, right? And draw whatever version of pictures help make sense out of this. Sometimes you can draw, two pictures side by side. Here's my main program, here's my net thread, and sort of imagine what happens when the players do what they're supposed to do. And if it's supposed to be player 2's turn and I click my mouse, right, if it's not my return, I'm just going to return. I'm going to ignore it. The only time I'm going to send my coordinates to the other player is if it was legally my turn to move and I click the mouse. So the only time I'm going to receive coordinates from the other player is when it is that other player's turn. So I don't need to check in here to see if it's player 2's turn. I know that when I get a message from them, it's their turn, right? Unless they hack the code and they're coming in with a modified thing that lets them take 2 moves at once, right? in which case, they can hack your system or hack your NetDot program to cheat. So we're assuming that this is being done cooperatively. But, you could theoretically check to make sure that the other player has taken a turn. You don't have to do that. You can assume that people aren't going to, make a different client program to come in and inject moves in between your move and the next player's move and so on. So don't worry about maliciousness. Alright, so what's the punchline on the main gameplay? Take whatever you did in your mouse click and throw it into a separate method. Process click, for example. Change your mouse listener to change your mouse listener to call that process click. Make sure it works in PA4. Okay, so PA5, change your mouse listener to check to see if it's your turn. You can actually add this in later if you agree with yourself not to cheat and not to click when it's not your turn. You can put that check in later. But, get the mouse coordinates, call process click, send it to the other player. And then make a net thread that receives XY information from the other player, calls process click, and loops forever until the connection goes away. And that gives you the core gameplay.
I got a question.
Yeah.
Does NewThread actually create a thread like we discussed previously? And if so, how would you do it?
So make a class. You can call it netThread uppercase N if you want, that extends thread. And in your initialization, construct an object of that class and call its run method. Sorry, call it start method. And in the class declaration itself, all of this goes inside the run method, along with whatever initialization you need to do. And in your main program initialization, when you create that thread and you call it start method, that's the thing that creates the new thread and starts executing run. And that gets this thing going. And lots of debug messages are a really good idea here. Right? As you move through this, as you do initializations, as you create the thread and start the thread and so on, be very verbose. Add lots of debug messages, Thread has been created. Thread's run method is starting to execute. Waiting for XY message from other player. When you receive that message, print it out. Receive the following message from other player. Calling process click. Done calling process click. Waiting for another message. Right? Add yourself good, well-written, meaningful, descriptive debug messages. Because you've got, multiple things going on. You've got a mouse listener and you've got net thread, and those are interacting with an entirely different program's mouse listener and net thread. And so you've got, at least 4 threads running simultaneously. And keeping track of who's doing what is going to depend critically on making good messages in your debug statements. Alright, we still need to talk about the details of sending these coordinates and doing all of this initialization, and we need to talk about shutting the game down. But up to this point, other questions first. Alright, so how do we send coordinates? We know how to send a string, right? We did that in the sample code that we started the class with. So send XY coordinates to other player. Well, this is where I'm suggesting that you develop a simple protocol. And the protocol I suggest is to use a single line containing the letter C, a space, the x coordinate as an integer, a space, and the y coordinate as an integer. So if the user clicks at 10, 25, you would send a message C space 10 space 25. Use a print line, so it's got a new line at the end. Send that, to the other player, do a flush after it, and their net thread should receive that message. So their net thread gets the message C1025 and put that into a string, message. Alright, in the PA5 assignment, I suggested looking at the split method. So if you say message.split and you put a space in there, that will take this string, look for every place where there's a space, and break it up into an array of smaller strings. So you could say string bracket bracket pieces equals message.split. Well, if this is what message is equal to, this creates an array called pieces, and pieces will look as follows. Pieces bracket 0 will be the letter C. Pieces bracket 1 will be the string 10. Pieces bracket 2 will be the string 25. Got to do some parsing. You've been parsing since fall, right? All the parsing you've done in 224 with user input, 222 with user input. You get to do that now, but you get to do it in Java. And you're not parsing user input, you're parsing a message from the other player in this game, the client or the server side, right? So how do you parse this? Well, take the message, split it up on spaces, which in this case would make an array of 3 elements. The first element will be, the thing that came before the first space. Make sure that's equal to the letter C. So, if pieces bracket 0 dot equals C, well, maybe I would say if that's not the case, there's some sort of error, because I was expecting a message that began with a letter C. So if pieces bracket 0 dot equals C is not true, then I did not get the message I expected. So you can do a sanity check and make sure this is a C. And then if it is, I'm going to assume these two things are integers. So I can say pieces bracket 1, and I can pass that as an argument to integer uppercase I dot parseInt pieces bracket 1, and I could set that into an integer x. And integer y could be integer.parseInt pieces bracket 2. Again, you can assume that everybody is a well-behaved actor in this. So you're not going to get a message that says, C10 ha ha ha, where this integer.parseInt would blow up on ha ha ha. You're not going to get a message that just says C10, we're trying to use pieces bracket 2 is going to give you an array index out of bounds exception. So you can assume that everybody's playing the way they're supposed to be playing, right? And the code that you're talking to is doing the right thing. So you can take your message, split it into pieces, take those pieces, parse them using integer parseInt. That gives you XY coordinates. And then call process click, go back, wait for a new message.
Is there a reason why you want to add C as the very first element?
Just kind of because there's another message we can also receive, which is a quit message. And so the other message you can receive is just the letter Q. And if you receive a message that's just the letter Q and nothing else, we can take that to mean the other player hit the quit button. But yeah, I don't have a good reason why I put a C in the front, except, future expansion. So I may want to, embellish this game down the road. And maybe the person's going to tell me what color they want their lines to be drawn in. So I could have a message called, T for tailoring. And T would be followed by a color code to say, hey, use this color. All right. So to exit the game, right? I need to add a little bit more. If the person hits the quick button, I'll send a cue to the other player. And I'll exit. And on the net thread, if the message is equal to Q, then, shut down. So that adds the quit button functionality. Have a button in your frame and make an action listener so that if that button is clicked, you go ahead and you send a cue to the other player, and then you can just, exit gracefully on your side. The net thread, which is receiving messages from the other player, well, if it receives the letter Q, it says, oh, the other player quit. And so it can say, congratulations, the other player forfeited, you've won the championship, and then you can exit gracefully. So we've got two of the pieces done, right? We've got the main gameplay, and we've got the shutdown. And this is the part to work on first, right? Because we don't need to have the option to quit in order to test the gameplay. And we don't even really need to swap names to test the gameplay. We can just hardwire. For the sake of testing, we can make player 1, Barney, and player 2, Betty. And well, don't give them the same initial. Bad example. Fred and Wilma. And we can just hardwire that. And now all we've got to do is say, hey, can we share mouse clicks? And that lets us get all of this working. That's the biggest change from PA4, right? That's the essential new piece of this. It's the threading and the networking. So concentrate your efforts on those to begin with. And once you have this working, well, then adding the quit, that's something we can add extra. And then you can add this business of swapping names in the beginning. And that's sort of the third piece. And that takes almost no extra work. So in your initialization, somewhere you're going to, create a socket or a server socket to talk to the other player. Create the print writer and the scanner. And when you're done doing all of that, before you say I'm done with my initialization, just send a one-line message with your name. And then read one line from the other player. And then use this as the other player's name. So the name exchange happens in the initialization. And do the stuff like we did in the sample code, create the socket or the server socket. If it's the server socket, do an accept to get the actual socket. Construct the print writer and scanner, to client from client or to server from server. And then before you're all done, just do one print to the socket that contains your name, flush it, and then do one read from the socket to get your name, get the other player's name, and load that in the text field or the variable or wherever you're storing the other player's name, and then it's business as usual. Then we go on to this. Does that make some sense? Alright, so what are the action items here? Modify PA4 if you haven't already to take all the gory stuff you do in a mouse click and put that in a separate method. and change your actual mouse listener to just figure out the XY coordinates from the mouse event and call this method with that XY pair. That's just reworking the code, right? So, obviously copy PA4 into PA5. Do this on, the copy of PA4 called PA5. Don't break your original PA4 because you want to keep that for future use. So modify your mouse listener to put all of this stuff into a separate method. Add something in the beginning when you first construct the JFrame, something to create this socket that you can use to talk to another player and create the print writer and the scanner. And then add a change in here. Forget about matching the turns, right? Assume everybody clicks when they should click, and just add one line, right? So your mouse listener now is get the XY coordinates, call process click. Add one more line after this, which sends that XY message to the other player. And now create a separate thread in the beginning of your program that does this two-piece loop. Receive XY coordinates from the other player, call process click. And that should be enough to play a networked game against yourself. You have to modify the GUI, right? So you can say if you're the client or the server, you can specify a host name, and so on and so forth. I'm guessing people have that done already because that was stuff we went over a week ago. That doesn't involve any of the networking or the threading. So if that's not done, that should be pretty quick. And if it's not, you can hardwire stuff there. You could make two versions of NetDot, one for the client, one for the server. If you don't feel like messing with the GUI right now, you could make two versions of this, and one is always the server, one's always the client. And you can hardwire the names, and you can hardwire the IP name, the host name that you want to connect to if you're the client, right? If you want to just jump into this part, which I think is the really fun part of it, you can, not worry about modifying the GUI yet. Do GUI free Wednesday and just do this stuff and this stuff. And that's the real workhorse of PA5. And the major new piece of it is this net thread. Because it's got to hang out and continually wait for connections. And we can't do that inside the mouse listener. Otherwise our windows won't draw properly.
I'm still looking at the thread method that you made and trying to figure out how that could be done syntax-wise. So
Let's...
What?
No, go ahead.
I was gonna say, for proceeding from a player process thing, don't you have to put that inside like a run method in order to execute?
Mm-hmm.
So I remember we talked about threads, and how a thread must have like a run method in order to execute at the exact same time as another thread.
Correct.
So, is that what we're doing for PA5 as well? Creating two identical threads that run at the exact same time?
Mm-hmm. Correct. So you're going to have sort of your main thread, which is, the thing that's running when you click a mouse. It runs your mouse listener. That's already a thread, but we don't really think of it that way usually. It's just our program, right? But it's actually one thread. So we're creating a second thread. And so we can do something like this. Where are we here? Let's go back to the server side. So we do our initialization, and we'll make a new thread to do something. Right, that's all I got to do. And this constructs an object of type myThread. And that can, do some initialization if I needed to and so on. But mainly I'm going to call that object's start method, and this right here is going to create a new thread and then call that thread's run method. And so in here, what I do is I do class myThread extends thread. I don't have a main program in here, but instead I have a public void run. So let's see if we can avoid crashing my machine. While still doing something slightly annoying. So we want our new thread to, you know, wait for a message from the other player and then call process click. But just to illustrate this, right, I'm going to create a new thread that just, you know, spews output on my screen. I'll make it a little less bizarre. I'll print out a message, but I won't do the new line. So my thread is something that, you know, when you call the run method, it just forever spits out this message. This is a separate thread. And in the beginning, before I go ahead and I do all of this business, actually I'm going to just do this in the very beginning. The very beginning of this, it's just going to go ahead and create this thread and call its run method. And so this is going to do the following. Right. So it's throwing output on my screen, right? It's clearly in that while loop, but I can still come in here and I can run my client code and it will, I'm in the wrong directory. I can run my client code and it connects to the server, and a message flew off the screen saying, you know, that it had gotten a connection, but I can type a number in here and the server will send me back a response. So I've got two separate things happening here. I have a set of code over here which is waiting for a message to come from the client, and this is a blocking call. When I call this, I don't come back from this call until I get that message from the client. But while that's happening, while that is blocking, this is still doing its thing. It's still generating output. So this, instead of generating output for PA5, would be, you know, waiting for a message to come in from the other player and then calling my process click code. But setting it up is really just a matter of construct the thread, start it, and in the thread itself, right, just make a class that extends thread, and whatever you want it to do, put it in a public void run method. And this is where Java is, you know, arguably so nice. And here, you know, I exited, and my main program in my server class normally exits after the client terminates, except there's a second thread, which is saying, you know, this is a separate thread, and it's printing that out. So this will keep running forever. If I try to reconnect, well, you know, it already closed down the socket connection. But this second thread has kind of its own execution, except I can Control-C it from the keyboard. All right, good for now. So PA5, I'm trying to make a little more simple than it might be. And the thing that makes it a little more simple is that this net thread can hang out here and wait for a message and call the mouse click. And other than, you know, swapping names in the beginning, it never has to send anything to the other player except, you know, when you're ready to quit. And so the way that this looks, if we were to sort of track out what the turn of events is, so here's player 1 and here's player 2. So player 1 is the server, player 2 is the client. And player 1, you know, click. And player 2 is waiting for click. So we can draw like a timeline. So player 2 is waiting for a click message. Player 1 is wait for a mouse click. So both sides are waiting. Player 1 actually gets a mouse click. It sends that to player 2. At that point, player 2 says receive CXY message. Process. And then basically wait for a mouse click. And effectively, player 1, after it sends the message to player 2, it waits for a click message. I guess I can put that up here. It waits for a click message. And when player 2 clicks the mouse, it sends that to player 1. And player 1 has been waiting for a mouse click, so now it receives CXY message and it processes. And then it goes back up here to waiting for a mouse click. And this goes back up here. So this is a fairly well controlled situation, because P1 is waiting for some local event, P2 is waiting for a message. When P1 gets its event, it sends a message, and then P2 waits for an event, P1 waits for a message. P2 will eventually send a message, and then P1 will go back to doing something, and P2 will wait for a message. So we always have one side of the connection waiting to receive a message, and the other side waiting for some local event to happen, an actual mouse click. And we never have a danger of both sides waiting for a message from the other side, right? Except when we exchange names in the beginning. So either player 1 is waiting for a message and player 2 is going to eventually send it, or player 2 is waiting for a message and player 1 will eventually send it. And we're guaranteed that there's this kind of, you know, lockstep behavior between the two sides. This gets more complicated if, for example, you were to write a chat program. So a chat program, you have two participants. Let's call them player 1 and player 2. And if player 1 says hello, and participant 2, you know, receive the message, and then it sends a message to player 1, and player 1 receives a message and sends a message. Right, we could write a chat program pretty easily. The complication comes in, what if player 1 wants to send 5 messages to player 2? What if they want to say, hello, 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 hold on a second, I'm busy. And this person is going to receive a single message and then send a message back. Right, for a chat program, you can't expect both sides to take turns. If you said, you know, this person sends a message, and then this person, and then this person, and this person, and they take turns, like we're doing in PA5, we can code that pretty easily. But it becomes more difficult if we can't control when each side of the conversation is going to want to transmit. And so let's see what's going wrong there. So participant 1, here's what our code could look like. Read a message from the keyboard. Send it to person 2. Read a message from person 2. Print on the screen. Go back up and do this again. So that's the first person side of this chat program. Person 2, well, since person 1 is waiting to read a message in the beginning, we're going to let person 2 talk first. Sorry, player 1 is going to read from the keyboard, send to person 2. So player 2 is going to start off listening. It's going to say, read a message from player 1. Print on the screen. Read a message from the keyboard, send that to person 1, and go back in loop. Alright, so how does this work when this runs? Program 1 is waiting for a message from the keyboard. Person 2 is waiting to read a message from person 1. Person 1 types something on the keyboard, hits enter. Now their program sends that to person 2. And now this is waiting to read a message from person 2. Person 2 reads the message from person 1, prints it on the screen, waits for a message from the keyboard. When person 2 types something and hits enter, that gets sent to person 1. Person 1 has been waiting for a message, so it receives that message, prints it on the screen, goes back up here. Person 2 goes back up here, and we're back at the beginning. But here's what happens when somebody wants to filibust, right? Person 1 wants to send a bunch of messages to person 2. They got a lot on their mind. So person 1 reads a message from the keyboard. Person 2 is waiting to receive a message. So person 1 hits enter. The message gets sent to person 2. Person 2 receives the message, prints it on the screen, waits for a message from the keyboard. Person 1 is waiting to receive a message from person 2. If at this point person 1 starts typing a bunch of messages, hitting enter after each one, none of those are being sent. This person 1 is waiting to receive a message from player 2. And the person at the keyboard might be saying, hello, enter, are you there, enter, I have some things to say, enter. That's all just being buffered up. Because the code for person 1 is at this point where it's saying, hey, wait for a message from player 2. And until player 2 types something and hits enter, it's not going to move beyond this point. It's not going to send anything to player 1. Player 1's not going to get beyond this point. So it's not exactly a deadlock, but it kind of feels similar, right? It's locked because we're waiting for the second person to send a message. And whatever this person types from this point forward will not get sent until this person sends a message. Type something in, hit enter, that gets sent, that gets us past this read, prints it, now we'll read the next thing the person typed and send that. But now we're going to have to wait again. So it's strictly, message, 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 message. And that's not how chat programs work. Maybe it's how they should be. It's like a talking stick, right? You can only say one thing in this case, and then the other person gets a chance to talk, and you can't say anything until they've said something. So if we want this to work like a more conventional chat program where this person could be typing, one message or 100 messages or no messages while this person is doing the same thing, this is where we need threads. And so we can make this work the way we expect by breaking it into a pair of threads. And again, this is not for PA5. You don't have to do this for PA5. This is, we're done talking about PA5 for now. We're going on. This is a broader topic. This is how we can do two-way communication and take advantage of threads to make that work. So here's what person one's program will look like. It's going to create a pair of threads. The first thread is going to do the following. Read a message from the keyboard, send that message to person 2, and go back up. The second thread is going to do the following. Read a message from person 2, print that to our screen, repeat. And this is exactly the same code that the other person is going to run. It's going to start off, it's going to create a pair of threads. The first one is going to say, read a message from a keyboard. But this is going to say, send it to player 1. And the second thread is going to say, read a message from player 1. Print that to our screen. Go back up to the top. And now we've got a nice asynchronous full duplex communication system set up. Because if person 1 is typing a bunch of messages, hitting enter after each of them, what happens? This thread sees the first message, right? They hit enter, it sends that message to person 2, and it goes back up and waits for another message. They type another message, hit enter, that message gets sent to person 2, and so on. And so if this person types 20 messages, all 20 of those get sent to person 2, independent of whether or not it's received even a single message from person 2. Because this is happening in a separate thread. Meanwhile, over here on person 2's side of the world, this thread is waiting for a message from a keyboard. Well, they're off in the kitchen making a cappuccino, and they're not looking at their keyboard. But this thread is running, and it's reading a message from person 1, printing it to the screen. So each of the messages that this person typed and hit enter is showing up on this person's screen. Now they walk back into the room and they look at the screen, and it's got 20 messages on it. And that's exactly how you want this to work. So the sending and receiving have been broken into separate tasks that can run independently of each other. And so if we wanted to do kind of a general purpose chat program, we would end up with, a total of 4 threads in play. Plus, whatever the main program thread is. So multiple threads here. But this is basically this business of not being hampered by these blocking reads. And when we first talked about networking, or about threading a few weeks ago, we use the notion of a blocking input, and the idea that when we're waiting for a message from the other person, we're stuck there. We're not going to move beyond this until the other person hits the enter key on their keyboard, which causes a message to be sent. But if this is happening in a separate thread, we don't care if this thread is stuck right here, because this thread is continuing to run. It's continuing to receive input, print it out, send it to the other player, and so on. Now, if we really wanted this to be a full-fledged chat type program, we need some more threads. So we create one server socket in the beginning. And we have one program running called a server, which is, creates that server socket, waits for a connection, and so on. But what if we want that one server to handle multiple connections? And so our server might actually look like this. Construct the server socket. Accept a connection. Well, once we accept that connection, we're going to go into this business of, read a message from the client, maybe do some processing, maybe send a message, etc., etc. Right? We've got, our square root server, reads a message, parses it as a double, calculates the square root, sends it back, or whatever, right? The issue right here is, once we start doing this, we're in a loop. And once the client exits, maybe we could go back and we could say, okay, let's accept a second connection. What if two people want to be using the square root server at the same time? Well, if my square root server is written like this, I can't accept another connection until this first client goes away. And then I can exit this loop, my has next line will return false, and I can go back and accept a new connection. So instead, here's what I'm going to do. After I accept a connection, I'm going to make a new thread, which is going to do all of this stuff, but my main thread is going to go back and accept another connection. So this is how most servers actually work. They construct a server socket, they wait for a connection request, they accept that connection request, but then they create a new thread to manage that connection. And the main thread goes back and just waits for another connection request. And so if we have a web page server, 5 different clients can connect to it and be, slowly at human speed asking for different web pages, and they can do that without interfering with one another. Because the server itself, after it got that connection request and accepted it, made a new thread to, get the particular message. Oh, here's a get statement. Let's go ahead and find that page, pull it out of the file, and send that back to the client and wait for another request. It's doing all of this in a separate thread. And the main thread just went right back to listening for more connection requests. And so if we had some kind of, server-based chat program, this process down here would then be broken out into 2 separate threads. One for, receiving from a client, one for sending to a client. And then our main thread would continue accepting. So this is one of the first, sort of genuine applications of threads that we encounter in here, and it's a fairly common use case. And this is also where, denial of service attacks can come in. Because if I'm not careful, if I just do this in some willy-nilly way, somebody can write a program that just repeatedly tries to connect to my server. Well, if I just accept every connection request and I make a new thread, I'm quickly going to create, tens of thousands of new threads, and that's going to crash my system. And if somebody knows that, maybe a competitor, they can wait till the day of my big demo, and as I'm about to present my bid for funding, they can start coming in and making, 100,000 connections to my server, and my server creates 100,000 threads and my machine crashes. And I don't get my money, and my competitor gets the money instead, right? So this is where, we start to think about, once we're networked, right, what does that mean? And we don't need to worry about this for the most part. We certainly don't need to worry about this with NetDot, right? Because we're not doing any of this stuff. We're just, accepting one connection, playing the game, and then exiting. But if we wanted to worry about this, it's not too bad. So server socket, when we construct it, it's got a maximum queue length for incoming connections set to 50. So the server socket won't be overwhelmed, right? But if we write our code to automatically create a new thread every time we get a connection request, yeah, very easy to put in slightly staggered connection requests and, compel the server to create a ridiculous number of threads. So, thread count equals 0, except if TC++ is bigger than 10, either wait or, reject the connection. Or, okay, so I would probably do this. Make a new thread, increment thread count. And hopefully we have some way to know when this thing exits and decrement the thread count. And up here, before I make my accept, I would say, if thread count is bigger than 10, then we're going to wait for thread count to come down. And that'll stop us from, inadvertently creating 10,000 new threads. But this starts to get a little trickier, because now we can't just create a thread and go on with our business. We need to monitor that thread. We need to know when this thread exits so that we can decrement the thread count and say, okay, I can accept one more connection request. And so we need to get into some more housekeeping. And if we have multiple threads that are all trying to update this shared thread count, now we get into these non-atomic read, modify, write issues. And so we would need to synchronize access to this so that two threads don't inadvertently try to decrement the thread count at the same time. If that happens, one of them might not get counted. And it's possible, if the timing is really bad, that we could end up, running only one thread at a time because our thread count is currently 9, but there's actually no threads running. And we get one connection request, we start a thread, we set the thread count to 10, and now we won't accept any more connections. And we're not going to see any compile errors, we're not going to see any warnings, we're not going to see any issues, except that it's going to look like our server is not running well. And maybe after 20 days of execution, this small error has gotten to the point I just described, where we've only got the ability to run one thread at a time. And maybe, somebody does some diagnostics. Maybe we're being told by customers, hey, I can't get into your server. And we start looking and we say, hey, there's only one thread. And so we'll start printing out the number of threads running at a time, and we'll see it dropping over the course of a few weeks. And maybe we'll start putting in some messages to log every time we get a connection request, and we'll start rejecting them instead of just not accepting them. And eventually we might find, hey, we've only got 3 threads running, but we're rejecting subsequent connection requests. Yeah, and good comment in chat, right? If you cap the thread count, then you're open to other kinds of attacks that can take advantage of that. So this is where, you know, it goes from quote simple Java programming to, you know, something very different. This is where a networking course and a security course and maybe some other courses would come into play, and your emphasis would shift, right? Not something we worried about for PA5. Again, this is beyond PA5, but it's just something to be aware of. And if you start doing, you know, client server stuff in a kind of, you know, professional level, an enterprise system that's going to be used by lots of people, especially people who aren't necessarily well-behaved actors, there's lots of potential for interesting issues. And none of these are particularly difficult to solve. The more difficult part is, you know, if you accidentally do something like, you know, try to track thread counts and you don't lock it or synchronize it, that may cause issues that don't show up until much further down the road and can be kind of hard to track, especially if this is one piece of, you know, a system that has, you know, hundreds or thousands of moving parts and millions of lines of code. So just stuff to think about and keep in the back of your mind, but nothing to sweat over. But it's a thing nonetheless. All right, so other questions, comments about that? So that's a good terminal point for this part of talking about networked communications and client server models, and it's you know, beyond what we need to do this last programming assignment. So there's no class Monday. It's Memorial Day holiday. Tuesday you can come to Open Lab in the office, the Zoom office, during Tuesday's class time, and I'll post that on Canvas tonight. And so Wednesday, a week from today, will be week 9, and we'll talk about the URL class, and we'll play around with making some web browser stuff. We'll do questions for PA5, of course, but we'll talk about the URL class, and then we'll be down to our last week. So our last week will probably pick up a few loose ends here and there, but also do kind of a wrap up on the course, talk about, you know, topics to study for the exam, so on and so forth. Possibly do a little bit of C++ just to see a different kind of object-oriented languages and so on. But URLs next Wednesday, and then we're probably mostly done with new material. So the end is coming quickly. All right. I will either see people in office hours or possibly an Open Lab next Tuesday. If not, I won't see you for a week. So have a fantastic week, and stay safe, and I will catch everybody next time, whenever that is. All right, thank you.